Hi, for this video, I will going to discuss to you some properties of vectors. In the previous video, we defined a vector is a physical quantity that must be specified by both magnitude and directions. And examples of a vector quantity are velocity, momentum, force, displacement. Equality of two vectors. The vectors A and B are defined to be equal if they have the same units, the same magnitude, and the same direction. That is, vector A is equals to the vector B only if A is equals to B and vector A and vector B point the same direction. For example, all the vectors in the figure are equal, even though they have different starting points. This property allows us to translate a vector parallel to itself in a diagram without affecting the vector. So in the diagram, these four presentations of vectors are equal because all four vectors have the same magnitude and point in the same direction. First, we discuss about vector addition. The rules of vector sums are conveniently described using a graphical method. To add vector B to vector A, first draw a diagram of vector A on a graph paper with its magnitude represented by a convenient scale, and then draw vector B to the same scale with its tail starting from the tip of vector A, as in the shows in the figure. The resultant vector, which is the vector R, is equals to vector A plus vector V, is the vector drawn from the tail of vector A to the tip of vector B. The technique for adding two vectors is often called the head-to-tail method. When vectors are added, the sum is independent of the order of addition. This independence can be seen for two vectors from the geometric constructions shown in the figure, and it is known as the commutative law of addition. As you can see in the figure, when vector V is added to vector A, the resultant R vector is the vector that runs from the tail of vector A to the tip of vector B. In the next figure, this construction shows that vector A plus vector B is equals to vector B plus vector A. Vector addition is a commutative, which is the application of commutative law of addition in a vector. Take note and keep in mind between the difference in vector addition and a scalar addition that vector A plus vector B is equals to the C vector is very different from A plus B equals to C. The first equation is a vector sum, which must be handled carefully, such as with the graphical method described in the figure. The second equation is a simple algebraic addition of numbers that is handled with the normal rules of arithmetic. Next, if three or more vectors are added, their sum is independent of the way in which they are grouped. A geometric demonstration of this property for three vectors is given in the figure. This property called the associative law of addition. According to the associative law of addition, where vector A plus the quantity of vector V plus vector C is equals to the quantity vector A plus vector V plus vector C. Geometric construction can also be used to add more than three vectors as shown in the figure. For the case of four vectors, in this figure, geometric construction for verifying the associative law of addition. The resultant R vector is equals to vector A plus vector B plus vector C plus vector D, is the vector that closes the polygon formed by vectors being added. In other words, vector R is the vector drawn from the tail of the first vector to the tip of the last vector. Again, the order of the of the summation is unimportant. In summary, a vector quantity possesses both magnitude and direction, and also obeys the laws of vector addition as described in the figure that I showed. Next, we discuss about negative of a vector. The negative of the vector A is defined as the vector that when added to vector A gives 0 for the vector sum. That is, vector A plus the negative vector A is equals to 0. The vectors A and negative vector A have the same magnitude but point in opposite directions. If we have the addition of vectors, then we have the subtraction of vectors. The operation of vector subtraction makes use of the definition of the negative of a vector. We define the operation vector A minus vector B as a vector negative B added to vector A, which is vector A minus vector B is equals to vector A plus the negative vector B. The geometric construction for subtracting two vectors is illustrated in the figure. Figure 12. Subtracting vector v from vector A, the vector negative b is equal in magnitude to vector b and points in the opposite direction. Yes, that's it for this video. In the next video, we will discuss multiplication of vector by a scalar and multiplication of two vectors. So stay tuned by clicking the subscribe button and turning on the notification bell for you to be notified for the upcoming videos that I uploaded.